This is a GCSE AQA chemistry question. It is from Trilogy Paper 2019 and it is a foundation question. So it includes a 6-marker. It has acids and alkalis, chemical formulae and exo and endothermic reactions. I'm going to recommend you pause on each section, have a go for yourself and then review. So here is part A and B, part C, part D, part E, and finally part F, which is the 6-marker component of this question. So now let's begin the review. The question is about salt. Ammonium nitrate is produced when ammonia gas reacts with acid. Give the state symbol for ammonia nitrate solution. Solution is the big clue here, but hopefully you're familiar anyway. Ammonium nitrate is a salt. When we make it, it means that we make an aqueous solution. So the symbol for aqueous is AQ in brackets. What's the formula of nitric acid? Fairly straightforward. You have got to learn this. Down here, we have got hydrochloric, nitric, sulfuric acids, and ammonium nitrate. All of those, hopefully, you are familiar with. So the correct answer is HNO3. On to part C, and we have got nitric acid being added to ammonia solution. Which row shows the change in pH as nitric acid is added until in excess? So the pH of ammonia at the start, we can immediately disregard pH of 2 because that would be a strong acid, and pH of 7 because it's neutral. Ammonia is a weak base. We can also look on the other side, and after an excess of nitric acid, we are going to have a pH below 7. So we can get rid of 7 and 10. So the only answer we have left out of all of the options is D. pH of ammonia is 10 at the start. We add an excess of a strong acid and it goes to a pH of 2. Correct answer is D. On to part C. Ammonia gas dissolves in water to produce ammonia solution. Ammonia solution contains hydroxide ions. A student adds universal indicator to solutions of nitric acid and ammonia. What do we observe? Again, this is factual recall. You've got to know the colours that we associate with universal indicator in acid, alkali and neutral. In nitric acid, it's red. In ammonia, it's blue or purple. On to part E, we have got calculate the percentage by mass of oxygen in ammonium nitrate. So we're told the relative formula mass of ammonium nitrate is 80, and we can see the atomic mass of oxygen is 16. But we have got 3 oxygens. So we will take our oxygen of 16, multiply it by 3, which means that 48 of the 80 in the MR comes from oxygen. Divide that by 80, multiplied by 100, and we have a percentage by mass of oxygen of 60%. And to finish off, we're going to look at the 6-marker. Describe a method to investigate how the temperature changes when different masses of ammonium nitrate are dissolved in water. So this relates to exo and endothermic, but it is about being able to craft a suitable method for a reaction. As always in 6-markers, we have got a levelled response. Level 3, you get 5 or 6. Level 2, you get 3 or 4. And level 1, you get 1 or 2. These grading criteria do very rarely change. Now we're going to take a look at the key information that we're looking for. So it's about making sure we do this in the right apparatus, a test tube. It's about making sure we insulate to prevent heat loss. Adding water to that insulated beaker or test tube. Measuring the temperature at the start, because otherwise we can't measure the temperature change. Deciding on a specific amount of ammonium nitrate to add, so it might be a gram or a spatula, but we specify. And then we make sure that we talk about stirring it because we want them to mix together. We want them to get the maximum temperature rise in the shortest time. Then we want to talk about, we measured the initial water temperature, let's measure the temperature after the reaction and work out what the difference is. So we've got a good structure for a method there, but remember we are comparing the temperature change when different masses are added. So we can then talk about repeating that whole experiment, but maybe with 2 grams, and then 3 grams, and then 4 grams. And finally, we can talk about control variables. So we will keep the volume of water the same. So a lot to think about there, a lot to consider, but to get to level 3, leading to the production of a valid outcome, all key steps identified and logically sequenced, there's a lot here that you can logically work through if you have a good understanding of the topic. And that's the end of the question.